When comparing gasoline and diesel engines, they appear similar at first glance. This is because they are both types of internal combustion engines, meaning that the combustion process takes place within the engine itself. As a result, they share many of the same components. They both have a cylinder block, cylinder head, crankshaft, valves, pistons, and connecting rods. Although gasoline and diesel engines look similar, the main difference is how they initiate the combustion process. Gasoline engines use spark plugs to ignite the air-fuel mixture with a spark. Diesel engines, on the other hand, use high air pressure to heat the air in the cylinder to a temperature that allows the diesel fuel to ignite on its own without the use of spark plugs. This condition is often referred to as autoignition. Although the components are similar, it is the method of combustion that distinguishes gasoline engines from diesel engines. In modern vehicles, all gasoline engines sold use a spark ignition system. This means that they require a spark from a spark plug to begin burning fuel. The spark plug receives power from the vehicle's ignition system. Older vehicles typically have an ignition system with a distributor, while newer vehicles use distributorless systems with coil packs or coil-on-plug setups. Despite the differences, they all have the same function: to ignite the air-fuel mixture in the combustion chamber. Diesel engines, on the other hand, start combustion solely by compressing air in the cylinder. Diesel engines compress air to a much higher degree than gasoline engines, making the air extremely hot due to the forced friction between molecules. When the compressed air reaches a high enough temperature at a compression ratio of 15:1 to 25:1, diesel fuel is injected into the combustion chamber. Unlike gasoline engines, which inject fuel earlier during the intake stroke, diesel engines inject fuel later during the compression stroke, just before the piston reaches top dead center. When fuel is injected into the combustion chamber with compressed and extremely hot air, it reacts quickly without the need for a spark from a spark plug, a condition known as autoignition. In diesel engines, fuel is injected directly into the combustion chamber through a nozzle. There, the fuel meets the preheated and compressed air. When the fuel meets the hot, compressed air, it ignites instantly. This rapid ignition process causes a large pressure surge, resulting in the characteristic knocking sound of diesel engines. This knocking is caused by the combustion process taking place at various points in the combustion chamber, resulting in uncontrolled combustion. However, as fuel injection continues, combustion becomes more controlled. However, the continuous injection of fuel into the combustion chamber can cause some fuel molecules to remain unburned, even though they would normally burn as the piston continues its downward stroke. Overall, while gasoline and diesel engines share similarities in their anatomy, such as combustion methods, ignition systems, and fuel injection processes, they have significant differences. The main difference between gasoline and diesel engines is how they perform combustion, even without looking at the engine itself. Just by looking at the tachometer in the car, you can see the difference. Diesel engines usually show a red line at the lower end of the tachometer, with an RPM range of around 4,500 to 5,000, while gasoline engines run at higher speeds, ranging from 6,000 to 9,000 revolutions per minute. There are three main reasons why diesel engines can't rev as fast as gasoline engines. Firstly, diesel engines need really robust internal components to withstand the higher combustion pressure, especially during intense combustion. Diesel engines need strong and heavy components to handle the pressure that occurs in each power cycle. This is because, if their internal components are more fragile, of course it can't handle the pressure. However, because of these heavier components, diesel engines are more difficult to get to high peak RPM, which results in a lower maximum RPM limit compared to gasoline engines. Another reason is that most diesel engines have an undersquare design, which means the piston stroke is longer than the cylinder diameter. While this design helps diesel engines generate high torque initially, it also limits their ability to rev at high RPM. The difference in maximum RPM and engine characteristics means that gasoline and diesel engines are suited to different purposes. Diesel engines are great for heavy-duty tasks like towing and hauling large loads because they can provide high torque at low RPM. On the other hand, gasoline engines are better for cars that need to go faster and have more power, like sports cars and performance vehicles. The third, and perhaps most important, reason why diesel engines can't rev as fast as gasoline engines is that they can't control ignition timing as well. In gasoline engines, you can adjust the ignition timing using spark plugs, the ECU, and ignition coils to get the best power at high RPM. However, diesel engines don't have this flexibility. In gasoline engines, we can control when the fuel burns to create the best combustion pressure as the engine speeds up. In diesel engines, though, combustion happens automatically when the air is compressed in the cylinder. While diesel engines can control when fuel is injected into the cylinder, this control is more limited than a gasoline engine's ability to control ignition timing. To put it another way, diesel engines can't rev as high as gasoline engines because diesel fuel burns more slowly than gasoline due to its working mechanism. This means that when the piston moves quickly, the ignition process doesn't happen at the right time, which reduces efficiency and power at higher engine speeds. It's also worth noting that diesel engines don't need to rev at high RPM to work well. They're designed to operate effectively at lower speeds and provide significant power when needed, like in heavy-duty tasks like towing and hauling large loads. Plus, diesel engines tend to be more durable than gasoline engines because they operate at a lower RPM range. To sum up, diesel engines have a smaller power range than gasoline engines, but their design, construction, and robust components make them highly durable and suitable for their tasks. They're known for their long lifespan and reliability. As we said before, the difference in compression ratio between over-square and under-square designs in gasoline and diesel engines also affects the structure and design of the engines. In gasoline engines, the shorter stroke allows for a more compact design and makes it possible to design with smaller cylinder volumes. However, this isn't ideal for diesel engines because the under-square design, which is better for achieving higher torque at very low RPM, requires more space to produce sufficient power to operate optimally. Diesel engines also have smaller empty spaces in the combustion chamber dome compared to gasoline engines, which means they can achieve a higher compression ratio. A higher compression ratio is needed to make the combustion more efficient. By compressing the air and fuel mixture into a smaller space, the combustion generates more torque on the piston. Diesel engines can have a higher compression ratio than gasoline engines because they can produce more power and efficiency from combustion. As the piston gets closer to the combustion source, the engine gets stronger. Also, with a higher compression ratio, diesel engines become more efficient because they can use more energy from the air-fuel mixture. Gasoline engines can't have combustion compression as high as diesel engines because of an issue called knocking. Knocking is when combustion happens outside the designated area, which can damage the engine. Gasoline engines usually use spark plugs to start the combustion process, which has to happen in a specific order. If you hear knocking, it means the combustion is too fast and uneven. Gasoline engines are more prone to knocking because they compress air and fuel together. If the compression is too high or the temperature is too high, the mixture can spontaneously ignite outside the flame front. So, to avoid knocking, gasoline engines need to have a lower compression ratio than diesel engines. On the other hand, diesel engines only compress air, and fuel is injected into the combustion chamber only when combustion is supposed to occur. This means there's no risk of spontaneous combustion, and diesel engines can operate more efficiently at higher compression ratios. Diesel engines don't have the same knocking issues as gasoline engines, so they can use higher compression ratios, around 15:1 to 25:1. Modern gasoline engines usually have compression ratios of around 9:1 to 12:1, with some reaching up to 14:1. However, gasoline engines with extra power from turbochargers or superchargers need to have a lower compression ratio, around 8:1 to 10:1. This is important to prevent knocking risk because forced induction systems already provide pressurized air to the engine. Gasoline engines with turbochargers or superchargers have lower compression ratios, so they're trickier to tune for peak performance. Now, let's take a look at how these differences make diesel and gasoline engines strong in producing torque and horsepower. Torque is basically the force applied over a distance, and it's really important for engine performance. In real life, torque is like the force you use when you're tightening a bolt with a wrench. The force comes from our hand, and the length of the wrench is the distance. If you use a longer wrench, you'll get more torque because you're applying the force over a longer distance. In an engine, the combustion process provides a push to the piston, which is similar to the force we apply with our hand. If the piston stroke in a diesel engine is longer and the compression ratio is higher, it means the combustion is stronger and generates more torque. Because diesel engines are more reliable at producing high torque, they're great for situations that require extra power, like heavy-duty work or applications that need more power. On the other hand, gasoline engines are better at making horsepower. Torque is important for tasks like towing and hauling, but horsepower is what lets an engine maintain high speed consistently. Gasoline engines can rev up to higher speeds and run more efficiently at higher RPMs, which makes them better at producing horsepower. That means gasoline engines are better for sports cars or other vehicles that need to be super fast. To wrap up, diesel engines are perfect for heavy-duty tasks because they can generate strong torque. Gasoline engines are better for high-performance cars because they can spin faster and produce more power. So, choose the engine that's right for the job or the speed you need. In an engine, there are parts like the connecting rod and crankshaft that move back and forth. Diesel engines have a longer stroke, so these components move a greater distance. Horsepower is the result of torque and RPM. Gasoline engines might not be as torquey as diesel engines, but they spin at higher RPMs, so they can get more work done in the same amount of time. Gas engines can make more horsepower at higher RPMs. In terms of how efficiently gasoline engines convert energy, they typically convert about 20% to 35% of combustion energy into useful work, with the rest lost as heat. Modern gasoline engines can do a bit better, reaching around 37% to 38% efficiency. On the other hand, diesel engines are more efficient because they can convert about 40% to 45% of combustion energy into useful work. Diesel engines are generally more fuel efficient because they can use combustion energy more effectively. There are a few reasons for this efficiency. First, as we mentioned earlier, compression is really important. By compressing the air-fuel mixture more, diesel engines can get more energy out of the same amount of air-fuel mixture, which makes them more efficient. One of the main reasons diesel engines are more efficient is that they use fuel more economically. The stoichiometric air-fuel ratio for diesel is a little lower, around 14.5 to 1, compared to gasoline, which is about 14.7 to 1. This ratio is the ideal amount of air and fuel for combustion. This is especially true for gasoline engines with forced induction systems, where higher incoming air pressure lets more fuel be injected into the combustion chamber. Diesel engines operate differently, though. They always use a leaner air-fuel mixture, which means there's more air than fuel in each combustion cycle. For instance, a modern turbocharged diesel engine can have an air-fuel ratio of around 16 to 1, which means that air is more dominant in the mixture than fuel. Even when it's working at its hardest, the mixture is still leaner than in a gasoline engine. The amount of air and fuel in the mix affects how gasoline and diesel engines manage their power. In a gasoline engine, when you press the gas pedal, the throttle opens and controls the amount of air that goes into the engine. The engine's ECU uses sensors to figure out the exact amount of fuel to inject based on the air that's coming in. Diesel cars are different from gasoline cars when it comes to using the gas pedal. In a diesel car, pressing the gas pedal doesn't regulate the throttle like in a gasoline car. Instead, it controls the amount of fuel entering the engine. Some modern diesel cars might have components similar to the throttle body in gasoline cars, but these aren't controlled by the gas pedal. Instead, the gas pedal in diesel cars is used to make the exhaust gas recirculation system more efficient. The main difference between gasoline and diesel engines is in the type of air-fuel mixture used. In gasoline engines, the air-fuel mixture is homogeneous, which means that the air and fuel are evenly mixed throughout the combustion chamber. In diesel engines, the air-fuel mixture is a bit different. It's heterogeneous or stratified, with only a small portion of the air mixed with the fuel. In diesel engines, there's more fuel than air in the mixture, which makes them more efficient. However, in gasoline engines, if there's more air than fuel, the operating temperature can rise, increasing the risk of knocking. That's why gasoline engines need to keep a more balanced mixture to stay safe and avoid any damage. One reason why diesel engines are more efficient than gasoline engines is that diesel fuel has longer hydrocarbons than gasoline fuel, which means it contains more energy in the same amount. In other words, diesel stores about 15% more energy in the same volume, which makes diesel engines more efficient. But fuel efficiency is just one factor when it comes to overall economy. Diesel vehicles, like cars and light trucks, usually cost more to buy. Also, these vehicles tend to sell for more when they're used because they're more complex and expensive to make. On the other hand, changes in pollution regulations and environmental awareness, including the Dieselgate scandal, have also affected how diesel vehicles are taxed and the legal aspects of them. This also affects how well diesel vehicles sell in different global markets. In some places where diesel vehicles were really popular, this is changing. That means the resale value of diesel vehicles isn't as stable as it used to be. The decision to own a diesel vehicle depends a lot on how you drive. If you're going to save money with a diesel vehicle, you'll need to travel quite a distance. However, if the journey is relatively short, a petrol vehicle might be a better bet. It's been thought for a long time that gasoline and diesel engines have a trade-off relationship in terms of CO2 emissions, nitrogen oxides, and particulate matter that are harmful to health. Diesel engines tend to produce less CO2 because they're more fuel efficient, but they also emit more nitrogen oxides and particulate matter. This has influenced environmental policies and consumer preferences towards diesel vehicles. The way diesel engines burn fuel makes them produce nitrogen oxides and particles. However, independent studies by global air monitoring agencies have shown that this picture is more complex. They did road tests to compare emissions from similar gasoline and diesel vehicles. The tests showed that there isn't much difference in CO2 emissions between gasoline and diesel engines. It's usually around 3 to 5 grams of CO2 per kilometer. Also, modern diesel engines that meet the Euro 6 emission standards or similar are also equipped with complex emission control systems. These include diesel particulate filters and diesel exhaust fluid injection systems that capture or chemically convert over 90% of nitrogen oxides and particulate matter. So, when they're properly maintained, both gasoline and diesel engines are pretty clean when they're new. However, there are some challenges when diesel and gasoline vehicles reach the used car market. It's a real challenge to find equipment to address emissions in diesel engines because it's so complex and expensive to replace. For instance, replacing a diesel particulate filter on a vehicle that's been on the road for 5 to 10 years could cost 15 to 30% of the vehicle's value. This cost can make it tough for owners of used diesel vehicles to afford replacement. So, some owners might look for ways to pass the emissions tests on their cars without spending too much money. Inspections are only done once a year, or even less often. Also, diesel engines are usually heavier and more complex, so they also produce more pollution during production. However, diesel engines usually last longer before needing to be replaced. On the other hand, what's enjoyable to drive is up to each person. Gas engines offer a wide range of power and produce less engine noise, which is good for the user. They're also more stable during maneuvers. While diesel engines are great for long-distance travel thanks to their strong torque and good fuel efficiency, although they're heavier, diesel engines are still enjoyable to drive. However, the weight of the engine can affect how the vehicle handles, especially on front-wheel drive layouts, which are more prone to understeer. Generally, diesel engines are great for adventure and long-distance travel. To wrap up, understanding the differences between gasoline and diesel engines gives you a good overview of how they behave and what they're good for. Whether you're looking for performance on winding roads or endurance in long-distance travel, there's a good chance one of these engines will be up to the task. Both types of engines have their own pros and cons. That's all the info we can give you in this video. As always, if you have any feedback, suggestions, or questions, please leave a comment below. If you enjoyed our video, Be sure to subscribe so you don't miss our latest content. See you in the next video, and thanks for watching. You win.